Under triangles, please, we are looking at the area of a triangle. And with that, the very first thing that you should write down is this: the area of a triangle, equals 1/2 times the base times the height. And usually, rather than writing out all those long words, it just looks like this: A equals 1/2 BH. Now, here is a very important thing. We may have talked about this with something else before, but okay, there is a difference between base and height and length and width. Okay? Base and height, whenever you see B and H in math, they are two lines that have to be perpendicular. Which means they have to form a right angle. If you do not see perpendicular lines with a triangle, you can't find its area. Now, let's look at one here. In the case of a rectangle, okay, let's say this is 8 inches and this is 12 inches. And because it's a rectangle, you know that all sides are perpendicular or form right angles. What is the area of this rectangle? They do 8 times 12 in their head. Wade's almost got it. Go, Wade. Go, Wade. He's writing it on paper. You, come on. Evelyn?
96.
Okay. The area of this is 96 square inches. Well, take a look, see. The beauty of that is this. If I connect the diagonals of this and remove and take away this side and this side, I'm left with a triangle. And what do you know about that triangle? That triangle is 1/2 of what this rectangle was, because that diagonal cuts it exactly in half. So you know the area of the triangle is 1/2 of that 96, and half of 96 is 48 inches squared. But it works nicely with this because the length and the width already formed a right angle, so you can call those the base and the height. Now with a lot of triangles like this, here's my triangle, and let's say this is, I don't know, 8 inches, and this is 6 inches, and this is 7 inches. What would be the area of that triangle? What would be the area of that triangle? Using the formula, area equals 1/2 base times height, what would be the area of the triangle? Nobody's jumping on ship on this one. Tyler? Drawing a blank? Brant?
49.
49! Are you guessing? Where does that come from? 7 times 7? Where's 49 come from? What's that? Parker? Oh. Nobody's speculating there? Abram's got it, don't worry.
336.
336.
Absolutely.
You might be slightly askew on that.
Totally.
Now, maybe you weren't listening when I said, here's my formula for the area of a triangle. I said, in order to find the area of a triangle, you have to have the base and the height, both of which have to form right angles. And if you've not given any lines that form right angles, you cannot do the problem. What lines here form a right angle? None of them. And you know that in math, you might say, well, these two do. No, in math, they have to give you a corner if they want to tell you that. Otherwise, you cannot assume something that looks like a right angle is. You can't find the area of this until the book gives you something like this. They will draw a dashed line, and they'll put a little corner on it, and they'll say, oh, that's 5 inches there. Now, once you have that, then, by the way, when you're given the area of a triangle, I expect you to write the formula for the area of a triangle down. Otherwise, 4 out of 5 mathematicians will have your writer's cramp again. Okay? You draw the triangle, you write the formula for the area of the triangle, and then you fill in the blanks. Area equals 1/2 times, and it doesn't matter which you call the base and the height. Usually we call this the base, but you don't have to because it doesn't matter the order. It's 1/2 times 8 times 5. The two lines that form the right angle are the ones you always put for the base and the height. So it doesn't matter the order you do this. Half of 8 is 4, and 4 times 5 is 20. So the area is 28 inches squared. Or another example of that might be this. Sometimes they do it like this. Let's say your triangle is an obtuse triangle like this. And this is 15 inches. And this is 20 inches. And this is 8 inches. The area of that triangle would be, Wade Davis?
You can't do it.
Thank you very much. We're catching on to this here. Because there are no, well, you write this down, area is 1/2 base times height. There are no right angles shown there. So the book is going to have to do it. They'll do it a couple ways. Probably on this one, they would do it like this. They would bring this straight down, and they would extend this line. They put a little corner here, and they'll say that this is maybe 6 inches, and that's all you need to know. 15 inches is the base. You don't have to go out there. This dashed line doesn't matter. It just shows you that it's extended out there. So your area is going to be 1/2 times 6 times 15. And half of 6 is 3. 3 times 15 is 45 inches squared. You have to be given a right angle. Boom. And the other thing is this, please, please, please emphasize this, because I can tell you tomorrow, the next day, most of you will forget to cut it in half. You'll just tell me that it's 30 or whatever, 90, and you have to cut. Triangles get cut in half because what you're doing is like finding a rectangle. You're finding it, and then you're cutting that rectangle in half. And then occasionally you'll be given a triangle that does look like this. Can I find the area of that triangle?
Yes.
Absolutely. Right here's your right angle. You're given that little square corner. Area is 1/2 base times height. It is always the two lines that form the right angle you use for your base and the height. Just because this is on the bottom, don't be thinking that that's the base, because it's not. It doesn't matter, but those two have to be your base and your height. Area equals 1/2 5 times 8. Doesn't matter the way you multiply. You can multiply 5 times 8 and get 40, cut that in half and get 20. Or you can take half of 8 and get 4, multiply by 5 and get 20. Whatever we're talking about here. Let's do feet squared and all that. But when you see these problems, you need to sketch out the triangle, you need to write the formula down, and then do the work. Is that not probably the most absolutely exciting thing we've ever done? Look at page 410, please.